We've chosen a standard render resolution for our image format. Now we're going to set up a render preset so that we can save the render settings in our render dialog in order for us to be able to recall these options at a later time. We're going to configure our render settings for a preview render quality that gives us a good balance between image quality and render speed. If you're continuing from the previous lesson, continue with the file that you already have open. Otherwise, click the Application button, Open, navigate to the Chapter 6 subdirectory, and open the file called Chapter 6 Facade01.max. Let's increment this file. Click the Application button, Save As. In the dialog, click the Increment on Save button, and this will save the 02 version of the file. Open the Render Setup dialog if it's not already open by clicking on the Render Setup button in the main toolbar. We're going to begin working in the Common tab, so make sure you have the Common tab open. If you've followed along, you've already set the output time to single and the output size to HDTV video resolution, and set the current rendering resolution to a setting of 320 by 180. There's no other features that we're going to change in this tab, so let's click the Rendering tab. Since we're going to be setting the draft image render setup that will give us a fairly decent quality image while optimizing the render time, we need to change some settings in the sample quality rollout. In the sample quality rollout, we're going to leave the samples per pixel at 1/4 and 4. What this will do is set the number of minimum samples to 1/4, meaning it will combine 4 pixels into one sample and does something called undersampling. The maximum number of samples is set to 4. This will divide a pixel into 4 and do something called supersampling. This affects the quality of the anti-aliasing of the rendered image. The lower these values, the lower the quality of anti-aliasing, and the less time it takes to render. For test renders, the default setting of 1/4 as a minimum and 4 as a maximum can work just fine. We'll leave the filter type alone. That's the algorithm used to determine how to anti-alias non-horizontal or vertical edges, and is not something we're going to get into in this lesson. The next thing we'll do to optimize our anti-aliasing speed versus quality is to adjust the spatial contrast values. What spatial contrast determines is where the switch or variation from 1/4 sampling and 4 times sampling happens. You can think of it as a threshold value. The lower the number, the more the sampling will occur, the better the anti-aliasing will be in your scene, because it will tend to do more sampling in the maximum range than the minimum range. As you increase the threshold value, you bring that switch or transition from the maximum to minimum more towards the minimum value. We're going to set the R, G, B, and A values to 0.2. Go ahead and click in the value for the red, type in 0.2. Click in the value for the green and type in 0.2. Don't forget to press the Enter button after you type in the values. This will ensure that your value is accepted by 3ds Max. Then type 0.2 in the green value and finally 0.2 in the alpha channel value and press Enter. That configures our anti-aliasing. The values we've entered give us a good balance between speed and image quality. Now select the Indirect Illumination tab. We're going to use the Final Gather for rendering this scene. So let's set some of the Final Gather values manually instead of using the preset slider. In the initial Final Gather point density option, type in 0.2, then press Enter to accept the value. This will increase the density of the points that Final Gather will use to calculate the initial Final Gather pass. This value goes from 0 to 100, but a value of 0.2 will give us a fairly good quality result, while not taking an extraordinary amount of time to calculate. Let's set the rays per Final Gather point to a value of 100. That means for every initial Final Gather point, 100 rays will be sent out into the scene to calculate the indirect illumination. Now, since we're using a low value on our initial Final Gather point density and our rays per Final Gather point, if we don't interpolate over enough Final Gather points, we can have a considerable amount of noise from the Final Gather in our image. To compensate for this and smooth the image out, we're going to set our interpolate over number of final gather points to a value of 90 and press enter. We'll set our diffuse bounces to 3. That will give us some extra bounce light, adding to the visual quality of the final gather solution. These settings will constitute our test render preset that we want to save. In order to save the preset that we can use to recall all the settings that we just changed, click on the preset down arrow at the bottom of the render setup dialog. At the bottom of the drop-down menu, click on the Save Preset option. In the Render Preset dialog, type in Test Render. Then click the Save button on the bottom right-hand side of the dialog. In the Select a Preset Categories dialog that comes up after you click Save, all of the options are highlighted by default. Hold the Control key down and deselect the Effects and Environment options. Click Save to save this preset. You can choose specific options if you only want a preset to change certain features of your scene like we just did. When you load that preset again, it will not affect the options that were not highlighted when you saved the preset the first time. We've just set up a test render preset that we can load at any time, even after we've changed settings in the render setup dialog, in order to render a consistent quality and size.